Good morning, students. I am Rahul Kumar Sahu from Kendriya Vidyalaya Tooting, Arunachal Pradesh. Today I am going to discuss second chapter of your class 9 NCERT book, that is matter around us pure? So as in the previous chapter, that is matters in our surrounding, we talked about what is matter. So if we will recapitulate what is matter, then we can know that the matter is a thing which has its own mass and it occupies some space. So in this chapter, as the question is itself, is matter around us pure? So we will talk regarding the purity of the matter. Regarding the purity of the matter is classified into basically two types. So as we know already, on the basis of the physical state, the matter is classified into solids, liquids, gas, and more like plasma and Bose-Einstein condensate. And on the basis of chemical composition of matter, the matter is classified into two main types. Those are pure substances and mixtures. So pure substances are of two types, which are elements and compounds. As you can see in this flow chart, the matter can be divided in on the basis of chemical composition into two types, which are pure substances and mixtures. In case of pure substances, the pure substances are divided into elements and compounds, and the mixtures are divided into homogeneous mixture and heterogeneous mixture. In this regarding this, we will be talking in our subsequent slides. Next, if we look at the differences between pure substances and mixtures, so pure substance is a substance which consists of a single type of substance. So it is substance which contains only a single type of substance, that is element or compound. So some examples of this pure substance are iron, copper, hydrogen, oxygen, water, sugar, common salt. So in this regarding this, there are some elements here which are iron, copper, hydrogen, oxygen, and some molecules like water, and some compounds like sugar and common salt. Next, regarding mixture, mixture is a substance which consists of two or more pure substances. Please look at this please focus here. The matter is consisting of two or more pure substances. So in mixture there are more than two pure substances. So some examples are seawater, minerals, soil, air, sand and salt, the mixture of sand and salt, sugar in water and salt in water. So there are some basic differences between these pure substances and mixtures. First is pure substances consist of a single type of substance, which we have already discussed, and the mixture consists of two or more pure substances. Then pure substances cannot be separated into other substances by physical methods. Okay, so in case of pure substances, we cannot separate it into other substances by any type of physical method, but mixture can be separated by some physical methods, as it is prepared, it is the mixture of two or more pure substances. Next, pure substances has its own definite properties, but mixture shows the properties of its components. So next, regarding this mixture, we will be talking more, and as we already seen in the flow chart, the mixtures are of two types. Those are homogeneous and heterogeneous mixture. In case of homogeneous mixture, it is a mixture which has a uniform composition. So the particles of the mixture are not visible by the naked eye. Okay, so first of all, in case of homogeneous mixture, in this mixture, the particles which are present in the mixture are we cannot see by our naked eye. Next, the particles cannot be separated by filtration or any type of physical method. The mixture is stable. Okay, so as these are uniform in nature, the particles do not settle down easily. They are mixed with each other. Then the path of a beam of light is not visible in the mixture. So in this mixture, if we will focus any ray of light through this homogeneous mixture, then we cannot see any path of beam of light through this mixture. homogeneous mixture. So if we will talk about some examples of homogeneous mixture, we have mixture of sugar in water, mixture of salt in water, mixture of copper sulfate in water, and these are some examples of the homogeneous mixture. The second type of mixture, that is heterogeneous mixture. From the name itself we will break down this word, like here in case of homogeneous, homo means same or similar, and this homogeneous means same type of substance. And in case of this hetero, whenever there is any prefix like hetero is there, then we can say that anything is regarding the different type of substances. So heterogeneous mixture is a mixture which has a non-uniform composition. Non-uniform means different. The particles are visible by the naked eye as the mixture is not properly mixed, so we can see the particles by our naked eye. Then the particles can be separated by filtration. Okay, so by the physical method of the separation, the particles can be separated. The mixture is unstable. Okay, as in case of homogeneous mixture, the mixture is purely properly mixed, so the particles do not settle down. But in case of this heterogeneous mixture, the particles settle down easily, and the path of a beam of light can be visible through this heterogeneous mixture. So what is this beam of light we will be talking in our subsequent slides. Next, some example of this heterogeneous mixtures are mixture of salt and sand. Okay, from the example itself we can tell that this cannot be properly mixed. Then the mixture of sulfur and iron fillings, then the mixture of oil and water. So as we know the universal truth of our universal truth, that is oil always floats on water. So in case of this mixture of oil and water, these are not miscible or mixed. Next, true solution. Regarding true solution, actually there are various type of solution, and before I will talk about what is solution. Solution is a mixture of any solute and solvent. So first, the word solute means any substance which are mixed in a solvent. Like if I will take any example, that is whenever we mix salt in water, so salt will be solute and water will be solvent, and the product or the mixture is called as the solution. So first of all, what is true solution? A true solution is a homogeneous mixture of two or more substances. So as this true solution has properly mixed substances, so these are homogeneous mixture. A solution has a solvent and solute, which I already discussed, that is it contains a solvent and a solute. So the component in the larger amount is the solvent. So as I talked I have already talked that in case of water, when we are mixing salt in water, so the solvent is the water, and the lesser amount which is present in case of any salt solution, that is the solute will be salt. Next, some more examples are solution of sugar in water, iodine in water, that is tincture iodine, which we use in our first aid or any medical in whenever we get an injury, we use tincture iodine. Then soda water. There are some properties of true solution. So first, the basic is the true solution is a homogeneous mixture. Then as it is a homogeneous mixture, the particles cannot be seen by the naked eye. Next, the solid particles cannot be separated, as it is similar to the properties of homogeneous mixture. Similarly, like the homogeneous mixture, the solid particles, that is one thing, one substance, one component of this true solution cannot settle down, and the solution is stable. Next, as this is a homogeneous mixture, it will not scatter any beam of light which is passing through it. And when the scattering of light is not taking place, then the path of light cannot be visible through this solution. So next type of solution which I'm going to talk, that is colloidal solution. So a colloidal solution or colloid. A colloid is a heterogeneous mixture of two or more substances where the particles, the solid particle size is somehow larger than the solution, true solution, and somehow smaller than the suspension, which I will talk in our subsequent slides. So for some examples of this colloidal solution are mixture of starch in water, mixture of egg albumin in water, the white portion of the egg, and the air, then the milk, and the air containing dust and smoke. So regarding this we will be talking. So first some properties of colloidal solution, that is colloid. So colloidal solution is heterogeneous mixture. It is a basic thing. Then as it is a heterogeneous mixture, the particles cannot be okay. So here is a means kick here, that the particles cannot be seen by the naked eye. As I already told that the solute particle size, the size of the solute particles is somehow larger than the solution and somehow smaller than the suspension. So the size, in this size range, the particles cannot be seen by our naked eye. Then the solute particles cannot be separated by filtration. Then the solute particles do not settle down and the solution is stable. So these are some means irony of this heterogeneous mixture, which is a colloidal solution. So please read carefully. Next, the particles scatter a beam of light. So scattering of beam of light is taking place in this colloidal solution, and what is that scattering of light we will be talking later on. So these are some common examples of colloids. So first, before I will talk about these different examples of colloids, I want to mention that in case of colloid, there are two types of phase. One is dispersed phase and another one is dispersing medium. As in case of solution, there are two things. First one is solute and second one is solvent. So in case of this colloid, first one is dispersed phase, first component is dispersed phase, and the second component is dispersing medium. Regarding this different this component of these colloids, you will be reading in our higher classes. So first, if we will be talking regarding this dispersed phase and dispersing medium and the states of this different dispersed phase and dispersing medium, regarding this there are various types of colloids and there are some examples of these various types of colloids. So you can read here. So if the dispersed phase is liquid and dispersing medium, where the this where the first component is getting dispersed, that is dispersing medium. So if the liquid is dispersed in gas, then the type of colloid is aerosol, and the examples are fog, clouds and mist. So in case of air, whenever there is water droplets are there, that is liquid in nature, so this type of colloid is called as aerosol. Next, when solid is in gas, solid is getting dispersed in gas, that is smoke, automobile exhaust, so this is also called as aerosol. Next, when the gas is dispersed in liquid, so it is called as foam. So as you have already noticed, in case of shaving cream, we found the foam is produced. So this is a type of colloid where the gas is dispersed in liquid. Then liquid that is called as emulsion, that is in milk, face cream. Next is solid liquid, that is salt. And in this type of colloid, some examples are milk of magnesia and mud, where solid is some silt or clay soil or means soil. Whenever it is dispersed in water, then we can found the mud, which is colloid in nature. Then gas solid, this is also called as foam. It is the foam, rubber, sponge and pumice. Then liquid in solid, that is gel. So some examples are jelly, cheese, butter. Then solid and solid, that is solid salt, that is colored gemstone and milky glass. Regarding this, you will be reading in your higher classes, so I will not go in details. Then the third type of different solution, that is suspension. Suspension is a heterogeneous mixture of two or more substances. So this in this case, in this suspension, the solute particles are the first component which is in the second larger component, that is the solvent. So the solute particles are larger in size, largest in size in these three type of solution. So in some examples are solution of sand in water, solution of chalk powder in water. So some properties of this suspension are: suspension is a heterogeneous mixture. First, the basic thing is suspension is heterogeneous mixture. The particles can be seen by the naked eye. Okay, as the particle size are larger or the largest in these three cases, then the particles can be seen by the naked eye. Next, the solid particles can be separated by filtration. So the by physical method, that is filtration, the solid particles can be separated out. Then the solid particles settle down. As the mixture is not properly mixed uh, solution, so the solid particles settle down and hence the solution is unstable in nature. Then the particles scatter beam of light. So similarly, in this case also, as the particle size are larger, it can scatter the beam of light which can be which is passing through this solution. So these are some illustration of the suspension. So solid particles can be separated by filtration. So in our next segment we'll be talking the separation different separation methods. Then solid particles settle down and the solution is stable. Okay, you can do a small activity where you take in a beaker you take, or in a mug you can take water, and in this mug or beaker you can pour some sand. So after some time, if you will look at your watch, then you can look that the soil the sand particles are getting settled down. So next, as I have already talked, the solid particles scatter light and the path of light is visible. If we will pass some light in this suspension, then we can see the path of light here. So this is a simple illustration of this, how the scattering of light is being taking place. The next important thing is the Tyndall effect. So first, regarding this Tyndall effect, the one major thing is that the colloidal solution shows Tyndall effect, and if you whenever through a window, whenever sun rays are passing, and inside the house, if there is smoke, or in the house if there are dust particles, then you can look like this beam of light here, as the illustration is showing here. Or in a forest, whenever there is fog and the sun rays are passing, then you can see like this thing. So these are some effect of this colloidal solution. It is the property of the colloidal solution, that is Tyndall effect. So basically, what is Tyndall effect? So when a beam of light is passed through a colloidal solution, the colloid particles scatter the beam of light and the path of light becomes visible in the solution. So basically, this is the scattering of light by the colloidal particles. And as this beam of light can be seen, and it is a very beautiful phenomenon. So this effect is called Tyndall effect. And Tyndall effect can be seen when light enters a room through a small hole due to scattering of light by the dust and smoke particles, which I have already told. And this Tyndall effect also can be seen in a dense forest due to scattering of light by water droplets in the mist or in the fog. Next, regarding solution, whenever you pour some salt or sugar in water, and if you will go on pouring more salt or sugar, then you will see that the salt or sugar is not getting mixed in the water. So whenever we are adding some more amount of solute in a given at a given temperature, then the solution will be not dissolved, or the solute will be not be dissolved. So this type of solution which can be formed is called as saturated solution. So it is a solution which cannot dissolve any more of a solute. If you will go on adding more solute, then the solute cannot be dissolved. So So this type of solution formed is called as saturated solution. Next is the solubility. Solubility of a substance is the amount of solute present in a saturated solution of the substance, and by this only we can find out the solubility of any solution. And similarly, the unsaturated solution is a solution which can dissolve some more of the solute at a given temperature. And regarding this saturated solution, if the solute if in a saturated solution the solute is not getting dissolved, then by increasing the temperature we can dissolve the solute particles in the solvent. So in your house you can also prepare saturated solution. So as it is a very simple activity where you can take some amount of water, like take 15 ml of water and add salt in one beaker with continuous stirring, and similarly add sugar in the other beaker which continuous stirring till no more sugar dissolves in it. So then you can get the saturated solution of salt and sugar. As I have already told, if the mixtures are heated, it dissolves some more of the solute. Next, these are some physical quantity of the solution. These are concentration of a solution. Regarding this, you will be talking in your higher classes more. But if I want to discuss some of this concentration of solution, first one is in concentration of solution, the amount of solute present is determined in a given amount of the solvent. So in this amount of solute is in the ratio of amount of solute and amount of solvent is here. So by this we can find out the concentration of solution, and also by amount of solute divided by the amount of solution we can find out the concentration of the solution. The concentration of solution can be expressed as mass by mass percentage or mass by volume percentage. So by finding out the percentage of the mass of the solute and solution, so by ratio of the mass of solute and solution and multiplying it into 100, we can get the mass by mass percentage of a solution. Similarly, by finding out the ratio of mass of solute and volume of solution and multiplying it with the 100, we can get mass by volume percentage of a solution. So these are all about how the purity, regarding the purity of matter, the different type of matters, and after that we discussed about the different types of solution, that is the true solution, colloid, suspension, a property of colloid, that is Tyndall effect, and after that we talked about saturated solution, and this one is the concentration, different physical quantity of this solution. So this is all about the first segment of your class 9 second chapter, that is matter around us pure. In our second segment we will be discussing a very important topic, that is the separating mixture in different the separating components in different mixtures. So this is all. Thank you and have a nice day.